Hi, my name is Charles.
Hello, my name is Gregory.
Hi, my name is Viola.
Hi, my name is Sarah, and in Chapter 11, we are going to be learning about areas of plane figures. 11.1 Areas of rectangles. Postulate 17. The area of a square is the square of the length of a side. Postulate 18. Area congruence postulate. If two figures are congruent, then they have the same area. Postulate 19. Area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. Theorem 11.1. The area of a rectangle equals the product of its base and height. Example 1. Find the area of each figure. A rectangle with base 3.5 centimeters and height 2 centimeters. You can solve this problem using Theorem 11.1. To find the area, multiply 3.5 and 2 to get the final answer of 7 centimeters squared. B. Find the area of the image below. You can solve this problem two different ways. The first way you can solve using the Theorem 11.1. To find the area using this method, multiply 8 and 5, then subtract that from the product of 2 multiplied by 2. That equals 40 minus 4, which gives you the final answer of 36. You can solve this problem using the second method, which is by using postulate 19, area addition postulate. Find the area by multiplying 8 and 3 and adding that to the product of 6 and 2. That equals 24 plus 12, which gives you the final answer of 36. 11.2 Areas of parallelograms, triangles, and rhombuses. Theorem 11.2. The area of a parallelogram equals the product of a base and the height to the base. Theorem 11.3. The area of a triangle equals half the product of a base and the height to that base. Theorem 11.4. The area of a rhombus equals half the product of its diagonals. Example 1. Find the area of the parallelogram shown. To find the area of this parallelogram, you must find the height. Notice that if you draw an auxiliary line to form a triangle, the triangle becomes a 45-45-90 degree triangle. Knowing that this is a special triangle, you can use the 45-45-90 degree triangle theorem to find the height very easily. The height turns out to be 4 rad 2. Now that you know the height, you can find the area using Theorem 11.2. The area equals 10 times 4 rad 2, and that gives you the final answer of 40 rad 2.
11-3 Areas of trapezoids. Theorem 11-5. The area of a trapezoid equals half the product of the height and the sum of the bases. A equals half h parentheses b1 plus b2. If you look at this example right over here, you see a trapezoid with the height of 7 and bases 12 and 8. Since A equals half b1 plus b2 equals, it will equal half times 7, which is the height, multiplied by 12 plus 8, which is the length of the bases. And if you do all the math, you will get 70, and that is the area. And that is how you find the area of a trapezoid. Section 11-4 Areas of regular polygons. Before I remind you of some theorems, I would like to remind you of some definitions. The center of a regular polygon is the center of the circumscribed circle. The radius of a regular polygon is the distance from the center to a vertex. The central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices. The apotherm of a regular polygon is the perpendicular distance from the center of the polygon to a side. The theorem 11-6. The area of a regular polygon is equal to half the product of the apotherm and the perimeter. A equals half AP.
(11.5) Circumference and areas of circles. The circumference of a circle is the perimeter around the circle. The formula is 2 pi r. The area formula is pi r squared. (11.6) Arc lengths and areas of sectors. A sector of a circle is a region bound by two radii and an arc. In general, if the measure of arc AB was x degrees, then the measure of arc AB would be x over 360 times 2 pi r. The area of sector A or B would be x over 360 times pi r squared.
(11-7) Ratio of areas. In this section, you will learn to compare the areas of figures by finding ratios. Comparing areas of triangles. 1. If two triangles have equal heights, then the ratio of their areas equals the ratio of their bases. 2. If two triangles have equal bases, then the ratio of their areas equals the ratio of their heights. 3. If two triangles are similar, then the ratio of their areas equals the square of their scale factor. Theorem 11-7. If the scale factor of two similar figures is a to b, then 1. The ratio of the perimeters is a to b, and 2. The ratio of the areas is a squared to b squared. This is explained further in example 3, where we find the ratio of the perimeters and the ratio of the areas of the two similar figures. The scale factor is 8 to 12 or 2 to 3. Therefore, the ratio of perimeters is 2 to 3, and the ratio of areas is 2 squared to 3 squared, or 4 to 9. Section 11-8. Geometric probability. The geometric probability problems in this section can be solved by using one of the following two principles. 1. Suppose a point P of line AB is picked at random. Then the probability that point P is on line AC equals the length of line AC over the length of line AB. 2. Suppose a point P of region S is picked at random. Then the probability that point P is in region R equals the area of region R over the area of region S.
Chapter 11 Review. If two figures are congruent, then they have the same area. The area of a region is the sum of the areas of the polygon of its non-overlapping parts. If two triangles have equal heights, then the ratio of their areas equals the ratio of their bases. If two triangles have equal bases, then the ratio of their areas equals the ratio of their heights. If the scale factor of two similar figures is a to b, then the ratio of perimeters is a to b, and the ratio of the areas is a squared to b squared.